Okay. So base dito, meron kang 2,400 Pascal. Now, this 2,400 Pascal, basically kasi, no, pagka meron kang structure, lahat ng load natin will be shouldered by the slab. Okay? So lahat diyan ka magsusuperimpose ng load. Okay? So we can call the ang tawag natin yan is the superimposed load. The superimposed load will be carried, okay, by the slab or throughout per square meter. Okay? Like for instance, if you are going to consider this floor, you have now the roof deck. Roof level. Okay? So meaning roof level. Kasi kung ito yung roof deck mo, meron kang stair dito, basically yung stair mo, lalagyan mo pa ng bubong yan. Now, normally at this floor, at this roof level, dito tayo naglalagay ng mga water tank. Dito tayo naglalagay, since this is the highest part of the building, so normally dyan sila naglalagay ng water tank. Dyan sila naglalagay ng mga, minsan naglalagay din sila ng antenna dyan. So yung mga essential facilities like antenna. Okay? So normally dito sa highest elevation, dyan inilalagay lahat yan. Now in this case, I am assuming na yung, since maliit lang naman yung slab natin dito, look at this. This is now our slab here. No? So meron kang stairwell dito. Okay? So basically on this roof, meron ka rin palang slab dito, class. Dito. Okay? So ngayon, kalimitan yan, okay, base rito is we use concrete here. So gumamit tayo ng concrete dito. Okay, that's why our load here becomes the slab. Okay, so the slab weight will be 2,400, and that was derived using the slab thickness, assuming that is 100 mm thick. Okay, so if that is 100 mm thick multiplied by the unit weight of concrete, that is 24 kilonewton per cubic meter. Okay, so you can solve for the slab weight, that is 2,400. So meaning yung slab natin dito, $240. So ganun pala kabigat yung isa. That is around 200 kilograms per. Okay? So dead load pa lang siya. Now, after you have you poured concrete here, sometimes hindi naman pantay yan. Okay? And since, okay, this is utilized for water tank, okay, or for roofing, so it should be waterproof. Okay? So ito yung waterproofing material natin. Naglalagay tayo ng waterproofing material. So yung waterproofing material natin, that is 260 Pascal. So meaning that is around 26 kilograms per square meter. So ano ba yung mga materials na ginagamit natin for waterproofing? We can use the 3-ply membrane. We can use a cementitious waterproofing. So basically, based on experience, okay, we have already computed that this waterproofing is already equal to 26 kilograms per square meter. So lahat ng materials na ilalagay mo dyan, meron kang shipping dyan, meron kang ilalagay na cementitious grout, meron kang ilalagay na membrane. So lahat yan nagkakarga ng mga 26 kilograms per square meter. Actually, medyo mabigat na ng konti yan. Okay. Now, aside from that waterproofing, naglalagay ka pa rin ng tinatawag nating toppings. So we need to put toppings above it. And these toppings, that is made of concrete, maybe lightweight concrete. Okay? Pwedeng it's a mixture of cement and sand. That will be the topping to be able to protect the waterproofing materials that is placed on top of the deck or the slab. Okay? That's why we have here 1150. That is the the unit weight. That is the superimposed dead load for tappings. Okay. Na-imagine nyo, class. So, kung ito yung slab, okay? So, this is now the thickness of the slab. Okay? And then underneath, minsan naglalagay tayo ng tinatawag nating ceiling. So, merong mga hanger yan. Okay? So, ito ngayon yung ceiling mo. Okay? Kung maglalagay tayo ng ceiling. But basically, syempre, kung tayo yung designer, we have to assume that in the near future, maybe maglalagay siya ng kisame, or pwede namang hindi kasi nasa naman yan, roof deck naman yan, at nasa itaas na yan. Pero kung maarte yung owner, dapat we have a provision for this ceiling. Okay? And that is approximately equal to what? Mga 6.5 kilograms per square meter. So medyo magaan na yan, 65 Pascal. Okay? Naintindihan nyo, class? And then on top of it, dito, naglalagay tayo ng tinatawag nating topping. Tapos, yung directly attached to the slab, meron kang tinatawag na waterproofing. Okay? So, meron kang waterproofing dito, and then meron kang topping. So, yan yung mga loads natin. And then you have now the electrical utilities. Of course, what are these electrical utilities? Nandito yung mga conduit, nandito yung mga wirings, nandiyan yung mga smoke detector. Okay, so anything about utilities, anything about mechanical, if there's a ducting, aircon, nandiyan yung mga exhaust. So basically, nandiyan yung mga piping. Again, we have to provide loads for that. So, itong mga loads na binigay ko sa inyo, ito na yung mga loads na ginagamit ko when I was doing a design. Okay? Kaya even after this subject, you can utilize or you can use all these loads for your design. Intindihan nyo? Again, that is simply for the roof deck. Now, sometimes kung papalitan natin yung floor level natin, mag-iiba naman yan. Halimbawa, gawin natin na yung floor level natin, that is not made of slab deck. Okay? That is not made of slab or concrete slab. Sabihin natin, that is made of roofing. Okay? Pwede rin naman yun. Gawin natin siyang roofing. If it is roofing, therefore, what are your dead load? So, kailangan i-define natin ano ba yung mga dead load natin at this level. Okay? So, sometimes we can use thermal protection. Okay? Ano yung thermal protection? Yung thermal protection na ginagamit natin, that is GI sheet. Okay? So, thermal protection using GI. Medyo nahirapan lang ako magsulat, ha? Yan. Okay? Siguro sabihin natin, that is made of GI sheet. What is the load of GI sheet? So, i-define mo lang dyan. What should be the equivalent load in terms of Pascal? Okay, so pagka GI sheet, kalimitan ang ginagamit natin, mga 650 Pascal. Okay, pag 650 Pascal, mabigat na yan. Kasama na lahat yan. Okay, why? 650 Pascal, okay, please note nyo lang, 650 Pascal, that is already dead load. It is made of GI. Okay, so dadagdag lang natin yan. Sometimes, yung yung ceiling na lang utility. Electrical, mechanical, and ceiling. So yan na lang idadagdag natin yan, meaning 650 electrical utilities, 60 mechanical utilities, another 60, and then ceiling is 65. So ano ang nawawala ngayon dyan? Yung trusses, GI roofing, framings, and everything, kasama na sa 650 Pascal yan. Okay, naintindihan nyo, class? Unless otherwise, gagamit ka ng rafter, yung mga rigid frame. So pagka rigid frame, iba yon, because that is a member weight, merong self-weight yun. Okay? But if you are utilizing a GI roofing, as much as possible, 650 Pascal is already enough for you to be safe in your design. Okay? After yung lahat ng yung mga previous warehouse na ginawa ko with Pepsi, siguro mga 7 warehouses yun. Actually, I only utilize, kasi masyadong malaki, I only utilize 600 Pascal. So 600 Pascal, like for instance, yung nasa Bacolod. Actually, the Pepsi Bacolod is around 95 meters. Yeah, 95 meters span. Wala siyang poste sa gitna. Okay, because kasi tatlong planta yon, so parang yung tatlong planta pinagsama-sama, hindi pwedeng huminto yung operation. Ang ginawa, naglagay ka ng bagong poste sa magkabilang gilid, pagkatapos nag-run ka ng Raptor na pagkalayo-layo, 45 meters, nagkita sila sa gitna. So, nung natapos na yung buong structure, tsaka lang tinanggal yung mga yung mga bubong-bubong ng mga existing line. Let's say yung warehouse 1, warehouse 2, warehouse 3. Okay, so pagka ganung mga kalalaki, usually you can reduce your dead load to 600 or to 550 Pascal. Okay, kasi masyado siyang malaki. Hindi naman lahat 'yon puro may puro may mga electrical utilities 'yon. But basically yung mga electrical and mechanical utilities nila, at hindi na rin naman naglalagay ng ceiling sa mga ganung warehouses. Ang nangyayari ngayon, they try to put ceiling sometimes on selected area, maybe on the office only, or sometimes on the production, or sometimes on the clean room. Okay, class, naintindihan nyo? Okay, so kailangan alam nyo yung mga weight. Like for instance, no? So, pag pinagsama-sama mo yan, you can get the total. That is the total superimposed dead load at this level. Dito sa level na to, ito ngayon superimposed dead load. That is 3995 Pascal. Okay? So, yan ngayon, gagawan mo ngayon ng reaction, line of action, yung ating slab, to be able to transfer this load directly to your beam. Okay? So it depends on what type of slab that you are using, whether it is a one-way reaction or either it is a two-way reaction para ma-transfer mo yung load going to the member. Pagka na-transfer mo na yung load na yan going to the member, yan, pupunta na tayo sa analysis. What type of analysis? Either moment distribution, frame analysis using Hilbert factor method, or using portal method. Okay, naintindihan nyo? We have now the live load at this deck. Okay, so the live load will be 1,900 Pascal. Okay, actually medyo nagulo rito, no, nung na-present ko rito, no. Pero nung binakita ko naman sa inyo, hindi naman siya ganyan, no. And then you have now the water tank. That is the self-weight of the tank. So, depende kung ano ba yung weight ng tank. So, i-impose mo pa rin yun kung ano ba yung weight ng tank. Okay? Now, basically, tank will be 85% full. So, you can calculate the water. Okay? Para ma-compute nyo kung ano ba talaga yung actual load na nandun. Now, the code also give us an information about the water tank. So, pwede kang maglagay kasi yan. You can assume a light storage, or you can assume a uniform live load for water tank. So meron naman siguro statement about that load. Okay, if none, we can simply calculate the weight of the tank. Okay, so you can calculate the weight of the tank plus the weight of the water. Okay, parang volumetric lang naman yan. And then you can compute using the unit weight of the water. So you can have the weight of the water tank. So, and that should be imposed here. Depende kung ano ang position. So ipapakita ko rin sa inyo yan pagka inilagay na natin yung water tank. Okay? So i-design natin ngayon yung slab na yan. Okay. So 1,000, why 1,900 Pascal? Because according to the code, kung ano ba yung kanyang type of occupancy, that will be the load that should be imposed at the roof deck. So, yan yung recommendation niya ng code. Okay? So again, on this note, nakalagay naman, okay, how these loads were derived. Okay? So even yung reference inilagay ko na. Okay? So that when you are amenable with this statement, so you can check with the code, okay? Including the table and the paper page. Okay, any question, class? Ano mo natanong? Hello?
Wala po, sir.
Okay, naintindihan nyo naman. So far. Paano lang? Ano, matrabaho ba sa subject natin? Hindi, nakakainip. Ano masasabi nyo? Nakakainip, no? Ano? Comment. Walang gusto magsalita. Huwag kayong problema sa subject ko. Kasi on my subject, automatic you will get a grade of A. Diba, wala naman tayong ano ngayon eh, wala naman tayong, tama ba? Wala naman kayong grade, P lang eh, tama ba? Ang galo nitong ano ko, no, second. Hindi, biro lang. Okay, class, ano, tama ba, grade natin, P lang? Bibigyan ko na kayo ng P, si Christian James. Bibigyan ko na ng P. No. Ano?
Ano man sabi niyo?
Ano? Hindi, bibigyan ko kadalayan naman kayo ng P. Okay? So ito, dagdag importansya lang to. Meron naman kayong sasabit sa akin. Tama ba? May sasabit yung computation niyo, yung calculations niyo. Pero kung ano yung natapos natin, yun lang isasabit niyo. Hindi na pahirapan yung sarili ninyo. Pero pipilitin ko na matapos lahat. Baka maiipit kayo nga. Obligado nyo tapusin. Tama ba? Hindi, gagawin ko mamaya, pasensya na kayo ha. Kasi actually in the past few weeks, alam mong hindi ako nakauwi, nasa dam ako. Kasi tinapos ko yung Botokan Dam. Pagpunta ko ron, hindi na ako kagad nakabalik kasi magka-quarantine pa ako eh. Ang mabigat, 3 pa sa mga tao ko nag-positive ng COVID. Kaya lalo akong hindi umuwi. Nag-quarantine muna ako ng 14 days. Kaya ang hirap pa naman ng ano ron. Kumbaga, ang hirap pa naman ng signal sa dam. Kaya hindi, nagpo-post lang ako nung Kaya pinadala ko sa inyo yung PowerPoint lang. Sabi ko, babawiin ko na lang yan yung last 3 meetings for you to discuss with you kung paano ba talaga ginagawa itong manually. Tapos pakitaan ko lang kayo ng sample. Hindi na lahat ng member, i-design natin at least isa-isa lang. Diba? Isang slab, isang girder, isang beam. Ang importante, malaman ninyo paano yung transfer of load. Paano natin kukunin yung load natin from the slab, going to the beam, going to the columns. Naintindihan nyo, class?
Yes po.
Okay. So yan, magsasabit pa rin kayo ng sa akin, ng requirement. Kagaya niyan, kasama na siya sasabit ko yan. So, i-prepare nyo na yung plan, i-prepare nyo yung structural plan, i-prepare nyo na yung structural load. Kung yun na natapos natin, yun lang, sasabit nyo, email nyo na lang sa akin. Okay na sa akin yun. Natindihan nyo? Okay, kaya lang, siyempre, mas gusto kong matutunan ninyo yung kung paano siya ginagawa lahat. Okay? At hindi naman natin matapos sa sa project natin. At least mai-discuss lang natin. Okay. So, sige, mabilis lang to. Next na tayo. Okay, so importante alam niyo na kung paano yung load ng kung paano yung load ng group level. Okay? Next. Roof deck level. So ito magkaiba to. Why? Kasi meron ka ng decks, meron kang balcony. And then the thickness, if you consider this roof deck level, okay, magkaiba yung roof deck level, yung kanina roof lang yon, okay? Extension roof yon para dun sa stair mo. Okay, kasi hindi pa pwedeng walang roof yung stair mo, mangyayari pag umulan, papasok yan ng tubig. Okay? Now, this one is roof deck. Ibig sabihin, ito yung part na pwede natin sabihin multi-purpose area to. Okay? Sometimes you can have your party here, okay, kasi ito yung pinaka-upper deck. Okay? And then again, we need to determine the superimposed dead load or the dead load, which we always start at the slab weight. Kaya lang dito kasi pagka mga residential, nasanay na ako pagka residential, ang maximum thickness natin 110. Wala lang yung 125. Siguro if it is school buildings, we can use 125. Pero madalang pa rin yung 125. We can only utilize 125 depending on the size of your slab. Tatandaan ninyo, pagka maglalagay ka ng beams, or sometimes kung hahatiin mo si slab, it should not be not more than 4 meters. Kung pwede nga, maximum of 3 meters lang. 3 to 4 meters lang. Pagka yan umabot ng 5 meters, automatic, maglalagay ka na ng intermediate beam. Natindihan nyo, class? Okay? Kasi pagka hindi ka naglagay ng intermediate beam, when you check for deflection for your slab, normally nagpe-fail yan sa long direction. Ang Ang nag-govern is the dead load. Okay? So as much as possible, we try to limit, kahit kung nag-framing system tayo, binanggit ko sa inyo, we try to limit the thickness, okay? O we try to limit the short direction between 3 to 4 meters. Tingnan niyo yung mapwa. Nasa 4 meters ba yan? Pero walang nag 5 meters. Pagka ang isang slab mo, halimbawa ito yung slab, umabot na ng mga 5 meters siya, let's say 5 dito, pagkatapos any length dito. Pag 5 meters, maglalagay ka na kagad ng intermediate beam. Kasi kung hindi, yung deflection yan, malaki na. Baka mamaya yung deflection yan, if you check under flexure, especially the deflection, minsan ano na yan, malapit na siya sa allowable deflection. Okay? So as much as possible, we try to limit between 3 to 4 meters. Okay? And if your thickness, if your slab is between 3 to 4 meters, and it is residential, usually the maximum will be 110 mm. Okay? So kung mas mabigat yung load yan, let's say school buildings o kaya mga hospitals, usually ang maximum nga mga 125. Pagka dinesign mo yan, lumalabas 125 ang maximum thickness mo. But for residential, kalimitan mga 4 inches lang yan. That will be the minimum. Do not use 3 inches or 75 mm. Okay? So if that is 110 mm, so times mo ng 24, that is 264. So wala nang problema. Alam na natin paano nangyari yan. Again, since this is a roof deck, okay? So we need toppings. Of course, we have toppings, that is 1150. Buti nga ngayon nakalagay sa code, that is only 1150. 1150, that is minimum design dead load. Please refer to table 204-2 NSCP 7th edition, page 2-4. So makikita nyo dyan yung mga minimum design load. So yung topping sata parang nandyan din. So, for concrete fill per mm is 23 yan. 23 Pascal times 50 mm thick, tapping kasi kalimitan 2 inches, so that is 1150. Actually, buti nga 1150 ngayon, no? In the past, we use 1,200. But normally, I use 1,200. But the latest code right now, define this tapping to 1150. Actually, hindi niya dinefine yung 1150, but nagkaroon siya ng recommendation that this filler is 23 Pascal per mm thick. Okay? But since our tapping is 50 mm, so we multiply it by 50, so lumalabas siya 1150. Kalimitan kasi ang tapping class 2 inches. Okay? Kasi halimbawa, binuhusan mo to, no? Hindi mo mape-perfect level, hindi mo naman male-level ng perfect yan. Kalimitan magkakaroon pa rin ng deviation yan. Okay? Hindi magpapantay yan, magkakaroon ng diferensya talaga yan. If you check the level here, hanggang dito, sigurado merong difference yan. Maybe a difference of 1 inch or a difference of 2 inches. But the maximum will be 2 inches. Huwag ka na maglalagay ng difference na 4 inches dyan. Problema na yan. Bakit? Kasi if you put a tapping to be able to level it, diba, dinoble mo na yung slab weight, napakabigat na nun. Okay? So we try to eliminate irregularities. Okay? Especially during construction. Kasi bumibigat yan. Nadadagdagan yung mga loads natin. Again, kung perfect ang pagkakabuhos niya, yung tapping natin mami-minimize. Siguro, 1 inch na lang. Okay? Kaya lang, yung 1 inch or masyadong manipis, sometimes that is prone to cracking. Okay? Nagkakaroon ng tinatawag ng mga temperature cracks. So, nagkakaroon pa rin ng problema yan. So, diyan nagsisimulan tumulo yung mga deck.
You have scissors.
Protected by the waterproofing. Okay, again, electrical utilities, mechanical utilities, ceiling, and then waterproofing. If you add all these things, that is 4235 Pascal. So ngayon, ano pagkakaiba nito tsaka dun sa nasa roof deck? Okay, ano pagkakaiba nilang dalawa? O ano pagkakatulad nilang dalawa? If you look at the previous slide, parehas silang walang movable partition. Okay, naintindihan nyo, wala silang partition. So, kailang papasok ang partition pagka nasa loob ka na. Okay. Again, live load, you have now the roof deck, 1,900. According to the code, 1,900 dapat ang ano natin dito, ang load na. It depends on the type of occupancy that it serves. Okay? So you have the exterior decks, balconies, that is 2,900. Again, you refer it to NSCP. Okay, so next. Now, can you see this fifth floor? So ano nadagdag? Nagkaroon ka na ng partition, movable partition. Again, nilagyan ko siya ng 3 asterisks. Okay? You can see NSCP section 204.3, paper page 2-12. Okay, so yun lang yung nabago. Okay, everything is the same. So pagdating sa fifth floor, second floor, third floor, fourth floor, lahat yan, if you add all these things, ito yung load mo. 4975 Pascal. Okay, ito hint ko sa inyo. When you design a residential, your SDL or the superimposed dead load shall not be more than 5 kilopascal. Okay, sa akin yan, 4975. Kasi pag lumagpas ka dyan, lumalaki na yung mga sections mo, lumalaki na yung mga columns mo, lumalaki na yung slab mo. Bumibigat na yung structure mo, namamahal na rin yung costs. Okay, naintindihan nyo, class? So, yun yung mga techniques. Ha? Kaya binigay ko na sa inyo. So, pwede nyo gamitin yan or you can derive your own provided it should conform to the requirement of the code. Okay? Any question? Next. So, roof deck. Sorry, ba't naging roof deck to? Fifth floor. Oh, mali na yan. Okay, sorry. Hindi ko na-correct yan. Okay? Dapat dyan, ano na lang yan? Residential. Okay? It should be residential. Yan. Oh, pangit lang na sulat ko. Okay? So, it should be 1,900. That is according to the code. Again, exterior decks, balconies, and everything. Kaya lang, maliliit lang naman yung mga balconies. Ang it serve is, hindi na magiging 2,900 yan. Possible. Pwede ng 1,900 na lang yan. Kasi maliliit naman yung mga balconies niya. Okay? So again, same thing with the, same thing with the fourth floor. Okay? So, same thing with the third floor. And then, same thing with the second floor. Okay? So, nalagay na natin lahat ng loads natin. Okay? So, other important design loads that we need to consider. Yung 6 inches natin. Excuse lang, class, ha? Okay, class, let's proceed. So, yung CHB wall partition natin, okay? So, that is 6 inches, 150 mm thick. So, normally, pag yung 6 inches natin ginamit, kita nilalagay yan sa exterior wall. Okay? And then we have now the interior wall partition. So, kalimitan, 4 inches to or 100 mm thick ang ginagamit natin. That is 2,100 Pascal. Yan ang load niya. Okay, etong mga loads na yan, actually, hindi mo na makikita sa code yan. Okay, so these are the product of experience na lang. Okay? Again, unit weight of soil, 18.4. Minsan kasi gagamitin natin yan, especially in the design of the foundations. Unit weight of steel, that is 77 kN per cubic meter. Ito, unit weight of concrete, 23.5. So, yung ginamit ko pala dun sa computation ko is 24. So, over-design na tayo ron. And then, provide concentrated load at the PN of the cantilever slab. That is 2.45 kN per meter. Okay? Kasi pagka may mga cantilever, okay, kalimitan na nilalagyan natin talaga na concentrated load because sometimes we use that for may mga baluster tayong nilalagay na, may mga railing, okay? So again, we can include that that concentrated load at the pre-end. For any cantilever, any design of structure that is made of cantilever, even without a load or any structure provided in the architectural plan, you need to provide at least 2.45 kN per meter at the pre-end. Nakindahan niyo, class? Any question? Ito lang yung pinakamahirap yung gagawin, makinig. No? Pero mas okay na to, palagay nyo. Wow! Class, any question? Tanong. Si Giancarlo, wala bang tanong?
Wala po na po, sir.
Huh?
Sigurado ka? Okay
Yeah.
lang, ha?
Yeah.
Si iba. O, next. Huwag kayong magalang, hindi natin tatapusin yan. Okay, so, okay, win load requirement. So, win load requirement, please, okay, refer to the code. Okay, so, ayan na yun. Anyway, ito laging tatandaan, no? For medium rise structure, let's say, 0 to, 0. Bakit kahit na 0 to, 0 to 0. May 0 pa, no? Medium rise structures, ito ng mga 10 story. Kalimitan din naman nag-govern yung wind load dyan. So, kalimitan na nag-govern dyan is what? The earthquake load. Okay, even if you get the load combinations, the one that always govern is the combinations of the dead load, live load, and the earthquake. Okay? Pero nilagay natin siya because there are instances wherein kung gagawin ba, kung i-design natin superstructure na maabot ng mga 40 story. So kalimitan merong effect yung wind load. That's why we need to check. Okay? Pero pagka mga medium rise, kalimitan earthquake lang ang nag-govern dyan. Okay? Masyadong maliit ang load ng wind load. Okay? To affect yung medium rise structure. Next, we have the seismic load requirement. So, location, that will be in Manila, seismic zone 4. So, if that is located in Manila, so depende yan sa structure ninyo kung nasaan. So, you have to identify what zone is it. And what should be the part of the actual vicinity or the location of your structure. Okay? So, you identify the seismic zone. Okay? And then, so ito, given na lahat yan, nasa code na yan. So I think class, familiar kayo dito sa seismic load requirement na to eh. Tama ba? I think this was discussed in your earthquake engineering subject. Tama ba?
Yes, sir.
Okay, so wala tayong issue dyan. Maganda pala to subject na to, no? Na-discuss na pala lahat sa inyo, no? Wala na pala tayong dapat i-discuss, no? Techniques na lang. Tama ba, class? Okay. So, ito, naka-identify. So, of course, pagka nagpe-present ka ng design criteria mo, dapat nakalagay yung wind load, yung load consideration, naka-define ano ba tong E, anong zone, anong velocity, anong importance factor, anong R, anong T, anong CT, anong HT. Natindihan nyo, class? So, alam nyo na yan, naka-define lahat dapat yan. Okay? And then, materials. Okay? So, under materials, we also part of our structural analysis to define the materials that we are going to use and its conformity. Okay, kagaya dito nakalagay yung footings natin, it should be 21 megapascal or 20.68 megapascal, pati aggregates and including the slump requirement. Okay, at 28 days and its conformance. So nakalagay lahat yan, footing, tie beams, grade beams. And then for columns, we use what? 20.68 megapascal. For beams and girders, we use 27.54. Slab on grade, that is 20.68. Others that is specified, 17.5 megapascal. So ito yung magiging design ng concrete natin. So when we design the columns, therefore our F prime of C will be 20.68. Now, usually ginagamit lang to from 0 to 5 floors. For any suspended slab, suspended members, we use 27.54. Okay? Pero pagka yung structure mo umaabot na ng let's say mga 20 story to 40 story, hindi na tayo gumagamit ng ganyang strength. Actually, we use much higher concrete strength. Let's say mga 7,000 o kaya 8,000. Yan na yung magiging compressive strength natin. Okay? Kasi masyado nang malambot yan. Okay? If it is a high-rise structure. So again, we intend to use a much stronger concrete. Next, rebar. Okay, so nakadefine din dapat yung rebar natin. It is conforming to ASTM 615 wherein the minimum yield strength will be 275. For bars that is 20 diameter and above, we use what? 414 or 415 Newton per mm squared. For sometimes they call it 414 megapascal. In some cases, they call it the grade 60. Okay? Yung class, grade 60. Okay, yung grade 60, ang equivalent niyan is 415. Pag sinabing grade 60, that is 60 KSI. Yung kasi time namin, no, ang unit namin is tips per square inch, KSI. Or sometimes they call it 60,000 PSI. Yan, English unit eh. Okay? So 60,000 PSI. So yung 275 na yan, that is the equivalent of grade that is the equivalent of grade 40. Okay? So yun yung grade 40. Grade 40, 40 KSI, 40,000 PSI. Okay? So naka-elaborate yan. Ano ba yung requirement natin for rebars? Okay? Including kung paano tayo magkakaroon ng splicing. Nakalagay dyan, that is 40 times bar diameter yung splicing natin. And at a certain zone, okay, your splicing should not be more than 50%. Ayan ba, meron kang column. So hindi dapat yan i-splice mo at a certain zone. Dapat at least 50% lang. The rest are continuous. Okay? So, next. Okay, for structural steel, minsan kasi gumagamit tayo ng structural steel, plates, angles, so everything. So, meron ka rin dapat specific instruction or specification for this item under structural steel. Okay, and then welding. Oh, thank you. Tapos na. Any question, class? So, kailangan dun sa mga plano ninyo, one by one, per floor, you have to define your load. Okay, pero hindi pa tayo tapos, ha?
Wow! Ang haba.
Okay, just define your load.
Nila.
Okay? So, teka, exit ko muna yan, ha? So, kaya paano ko ba exit yan? Okay, stop sharing. Okay, class. Question. Okay. Then let us proceed with the magdadagdag ulit ako ng files, no? Ano, i-stop ko ba yung recording? Sorry. Ano gagawin ko? Start recording uli ba, class? Tama ba? Okay, yan. Okay, class. So, any question? So, importante yun, ha? So, pagka gumawa kayo, you have the architectural plan, you have the... So, yun yung mga natapos natin. So, yun yung mga pwede nyo i-prepare. You have the architectural plan, and then after that, you have the structural plan. After the structural plan, meron ka ng design criteria. And then after the design criteria, we proceed with the loading diagram. So, may papakita pa akong presentation sa inyo. Ito yung kanina. Ito yung yung huli kong pinakita sa inyo, loading diagram. Okay? Although this loading diagram, the presentation is more or less on up to second floor lang. Actually, gagawin ko ngayon yung third, fourth, fifth, sixth. Okay, and then after that, na kayo, more on computations na.
Okay, Lucas, I'll give you 3 minutes. I'll be right back.
Why there's a spot? What? Why is that? I'm not even allowed.
Nick,
Yeah.
you need to drink only one vitamin.
Pwede palang sama-sama lang dito, no?
I drank.
Yes, I'm done.
Vitamin C.
Yes. Wait. Yes, mine.
Ready.
Oh. Oh, the earthquake.
Ah,
Come on, army attack.
okay class, let's proceed with this, with this next video. Ito, medyo maganda to. Okay?
Yes, Billy. Oh my God. Oh my God. Woo.
Okay class, itong presentation na to class, nakita nyo na to no? Actually, ginawa ko to.
Woo.
Okay? Okay. Now, if you look at this this presentation, okay? Ito lang class, ha? Hello. Yes, sir. Saan po sila? Oh, sir, kumusta? Okay. Sige po. Okay. Kala ko bakit. Thank you. Oh, okay. Okay, class. Sorry, ha? Okay. Here, no? We have now the loading calculations. Okay. So, dito gagamitin natin ngayon yung design criteria na sinet natin. Okay? So, wala pala tayong paano ba ako maglalagay ng blank dito? Okay, puntahan muna natin yun, Ayun, share whiteboard. Okay, class. Let's consider, no? Kasi yung slab natin, no, we know that slab, okay, lahat kasi ng load natin, in-impose natin sa slab. Okay? Together with the slab, okay, all the live loads, the dead load, the superimposed load, lahat yan, it will be shouldered by the slab. So together with the slab, okay, the slab will be our elements that will transfer the load directly to the girder or to the columns. Okay? So the tendency will be, there will be a reaction on the slab that transfer these loads. Okay? So normally, ang prinsipyo ng slab is that a slab can either a one-way slab or two-way slab. Tama ba? Ang sabi natin M, when M, which is simply equal to the ratio of the short and the long span of the slab. Okay, assuming that this is now the S, this is now the long direction of the slab or the dimension of the slab. If that is simply equal to less than 0.5, that is considered as what? One way, two way. Okay, if you recall, that is one way. Okay. Very good. Gabriel Alorcan. Okay. So that is one way. Okay. So if it is greater than or equal to 0.5, then it becomes a two-way slab. Okay. Now, so if this is a one-way slab, so basically the transfer of load will be directly towards that point. No? If this is one way, so therefore,
the
the direction of the load will be directed in one direction. Kaya mapapansin ninyo, no? There is only a one-way reaction. Now, if you recall, yung ano natin, yung support natin, okay? Pag one-way slab, normally mapapansin niyo is ano lang, one-way reaction. Diba? Laging nakaganon. Natatandaan niyo ba yung detalye natin? Diba? Yung details natin sa reinforced concrete, ganon. Diba? In such a way, this is simply equal to what? L over 4. Diba? Again, this is also equal to L over 4. Diba? Yan. So, nandiyan yung zero moment natin. Okay, the maximum moment will be located at the center. Now, in this case, ito yung ano natin ngayon. Ito yung reinforcement natin ngayon. And then, parallel to the long direction, we provided what? The top of the bottom bar. And then dito, nagpo-provide din tayo bottom. No? Now, what do you call this bar? These are what we call temperature bars. Okay? Temperature bars. So with reference to this one-way reaction, so we can conclude, okay, that the loads will be directed towards that direction. Okay? So if you have now a member here, okay, kung meron kang member dito, okay, this will be transferred in terms of a uniform load. Like that. In one direction only. And then you have now the reaction. Okay? And this load is simply equal to WS over 2. Okay? So parang yung load natin, wherein this load W, okay, is in terms of Pascal. Or sometimes we can use kilopascal. Okay, so if you recall, no, our dead load is simply equal to, ano ba yung dead load na 1.95 kilopascal. And our live load, if you recall, that is simply equal to 1.9 kilopascal. Okay? So these are what we call the W, or we can call this to be the W. Now this W, if we present it here, okay, that becomes a what? That becomes a kilonewton per meter squared. Okay, multiplied by the meter. Okay,
scroll up.
That is over 2. Okay, so that is W. That is in terms of, that is the S.
That's how to say
So in that case, meter squared. So maging unit natin, it becomes what? Kilonewton.
They go like if you go to Google Translate,
okay,
everything
so,
that
ganun siya natatransfer.
was written in Finnish is dog.
Moving to this direction and to that direction. Okay, so that is the reaction of a one-way slab.
You like the language, Diego?
When we consider the reaction of a two-way slab. Okay. Clear. Pwede palang clear, no? Okay, so clear ko muna, class, ha? Now, let us consider the two-way slab. Okay? For two-way slab, so the tendency is that the reaction of the slab will be in a diagonal form.
What? Okay. Okay.
Okay? So meaning, since it is a two-way reaction, So, merong load na pupunta doon in that direction, and you have now another direction papunta naman doon. Okay? So, it becomes a two-way reaction. So, there are loads that coming from the slab directed towards this beam. There are other loads that also going to this direction.
In the fridge.
Okay? Meron ding loads na papunta ron. Okay? Meron ding loads na papunta rito. Okay? Again, this line of action, okay, is what? Normally projected 45 degrees. Okay? So, considering this slab, we have now 4 support. Meron kang support dito. Most probably, meron kang beam dito. We have now another beam here. In here. Another beam here.
No, just why?
Sorry ka ng kamay ko. Saglit lang class Okay, so you have now beam here. So the tendency is that yung slab natin, the loads of the slab will be transferred in 2 directions. And it should be shouldered by the 4 elements of the beams. So you have now a load going to this direction, meron kang loads going to this direction, and you have now the loads going to the right and going to the left. So therefore, if you look at the reaction of the slab, it is a two-way reaction. Okay? So in that case, we can calculate the load directed towards this direction and towards that direction and towards this direction and towards this beam. Okay? So this one is simply equal to what? The equivalent weight will be equal to be able to convert this trapezoidal load into a uniform load. So it will be equal to WS over 3 multiplied by 3 minus M squared over 2. Okay? Where M is simply equal to S over L. Now, this is simply equal to S. This is simply equal to L. Okay? So, that is the uniform, let's say the equivalent uniform load. Nagintindihan nyo, class? I think this was already discussed sa inyo. Hindi. Okay? With reference to this one, okay, yung weight equivalent natin dito, converted into uniform load, that is WS over 3. Okay? Like for instance, no, let us try to consider this one. So if you have now this beam, okay, normally, this is our load. Okay? Okay, so this is our load. And then this is now our reaction. Now, if the load here is simply equal to W, okay, and then you have now a unit loads directed towards downward, and then the total length simply equal to S. Okay, so we can say that the reaction here is simply equal to WS over 4. Sus lang Mildred, bakit? Bakit? Yung pabayad mo ng renta, pagkatapos yung 50, bigay mo kay Jan, may pinabibili ako. Yung si Sarah, kukuha rin sa'yo ng ano. Ha? Bigyan mo si Sarah. Tsaka yung pambili ni Jeffoy ng penetran. Okay. So, sige, tingnan mo kung ilan ang mabibili niya. Pero, limitahan mo lang din. Ha? Tingnan mo kung may sukli. Wala akong pera eh. Okay. Si Jan, bigyan mo ng 50. May pinabibili ako eh. Okay, para maiuwi ni Mac. Ha? 50. Tapos yung sa renta, 20 plus kamo. Tapos si Sarah, bingin mo yung kailangan niya, tsaka yung kailangan nung kailangan nung budget. Okay. Na-count mo na lang. So, okay. Ayun na ako. Okay, class. So, ito yung natin, ito yung triangular load natin. Okay, now this triangular load must be converted into a uniform load. Yan. Okay. So, uniform load. Now, that uniform load, that is the weight equivalent. Okay, pasensya na kayo, class. Tumawag kasi yung isa kong tao eh. Okay, so, again, considering this triangular load, so you have now the W, you have now the short direction, and then you can provide the reaction, that is weight S over 4. Ganun din dito, weight S over 4. Tama ba? And then you can calculate, you can convert this to an equivalent load. Okay, by simply comparing what? The moment at the center. Yeah, moment at the center, okay, here. And the moment at the center here. Moment at the center. Okay? Naintindihan yung class? Okay? Yung moment at the center here, okay, is simply equal to WE, the equivalent, times S squared over 8. Okay? So this is now the S. Okay? So WS squared, that is actually, nasanay tayo. Okay. Lagyan natin L. Okay? LS. Yan, no? WL squared over 8. The moment here. Parang ang labo nito. No? Okay, so this is now the moment at the center using an equivalent uniform load. Now, what is the moment at the center here? Of course, the reaction, moment at the center here will be equal to the reaction times S over 2. Right? So this is now the reaction at that direction minus, okay, the centroid of this triangular, the load, okay, that will be equal to what? W multiplied by S over 2 multiplied by 1/2, okay, the triangular, multiplied by the moment arm. What is the moment arm? 1/3 times what? S over 2. Okay? So again, you put the equation of R, the equivalent R, WS over 4, and then you can equate these two. Okay? So you can calculate the uniform load WE, which is simply equal to WS over 3. Intindihan nyo, class. So this is how a two-way slab react. Okay? It reacts in two-way reaction. Okay? While one-way slab reacts in one-way direction. So in that case, you can calculate the equivalent uniform load. By simply considering this value, you can calculate the equivalent uniform load here. Okay? And then ganun din dito, using WS over 3, you can calculate the equivalent load here. Ganun din naman dito sa taas, you can calculate the equivalent load here. Ganun din dito sa gilid. You can calculate the equivalent load here. Intindihan niyo, class? Any question? Tanong. Ano na-solve itong WS over 3? Natatandaan niyo ba to? Wala na sumasagot ah. Hello? Narinig niyo ba ako? Mga na kayo. Natatandaan niyo ba, class, paano na ko yung WS over 3? Pamilya ba kayo dito? Hindi. Hello? Hello? O, tinuro po sa RCD. Thank you, Iho. Okay, guys, na-discuss to sa RCD, tama ba? The reaction of the slab. Hindi yung slab actually, kundi yung reaction of the slab. How slab react to the load.
Bro. My bag. Bro, just watching that. Oh no. Oh no.
Question, class. Naintindihan nyo?
I'm a random tap for you, girl. Video.
Vega, you gotta be hyped too.
I'm not as happy as
Come on, Diego.
Oh, the hair, man. So good.
Come on, Diego.
Woo!
Okay, class. Ano, question? Wala?
Bye.
Sige, text nyo lang, text.
Bro.
Okay. O, sige, good. Very good. Thank you. Okay. Tinuro naman daw sa RCD, sabi niya, no? Yung iba, ano sabi niyo iba? Okay. So, yun yung reaction ng slab. Okay, sige, anyway, let's proceed, no? Tanggalin na natin to. Teka. Ano ko ba babalikan yung ano kanina? Okay, class. So, balikan na natin to. Okay, so in this case, you have to provide your loading diagram. Okay, kagaya ng ginawa natin dito. Okay, we identify whether it is a one-way, whether a certain slab is one-way or two-way, and then we could identify the reaction of the slab, whether it is a two-way reaction or one-way reaction. In this case, most of our slab are two-way reaction, okay? Except for this slab. On this case, you have now a one-way reaction, so therefore the load here will be WS over 2. But in this case, you have now WS over 3, and on this case, since this is a trapezoidal form, so again, that is WS multiplied by 3 minus M squared all over 6. Okay, so ito na ngayon siya. Okay, for this trapezoidal. And then we try to convert it into a uniform loads. Okay, but before we convert into a uniform loads, let us first check this diagram. Okay, since that is a two-way, so ito nga yung reaction ng slab natin. Okay, you have a two-way reaction. But for the esters, ang tendency natin dito sa esters, kasi yung esters natin, ang support naman niya dito lang, tsaka dito. So ang tendency is WS over 2 lang yan. Yung load na pupunta ron, tsaka yung load na pupunta rito. So therefore, ang assumption natin dito, it will become WS over 2. Here, also is simply equal to WS over 2. Now, in that case, we need to convert this into a uniform loads, which is illustrated on this part. So mapapansin niyo dito naka-uniform load na siya ngayon. Okay. First, let us consider this slab. Okay? Considering this slab, okay, the trapezoidal form, which is this one, okay, the action will be directed towards that direction. Okay? Again, that is simply equal to 4.975, which is the W multiplied by 3.05. Ito, hinighlight natin, 3.05 multiplied by 3 minus the ratio of the short and the long direction, which is equivalent to 3.05 over 3.35 is squared of that all over 6. Okay? So ito ngayon yung load niya. That is 5.49 kilonewton per meter. However, for WS over 3, okay, along short direction, that is WS over 3, if we are going to substitute, again, what we consider is the load due to dead load. That is 4.975 multiplied by 3.05 over 3. Again, that becomes 5.05 kilonewton per meter. Okay? So, kaya dito nakalagay, along that direction, the equivalent uniform load is 5.05 kilonewton per meter. Itong nasa baba, 5.05 kilonewton per meter. While on this beam, the uniform equivalent load is 5.49 kilonewton per meter. Dito naman, 5.49 kilonewton per meter. Just for this slab. Okay? That is due to dead load. Okay? So, dead load pa lang yun. Next. Okay, next. Let's consider the slab provided. In this case, our is full live load. Okay? Now, substituting the following, again, the same. Ang nagbago lang naman yung ating 1.9. So, we can say that our unit is 2.09. Okay? And for WS over 3, that is 1.93 kilonewton per meter. So, ito na ngayon yun. So, nakalculate na natin yung equivalent uniform loads nito, both dead load and live load. Dito sa kabila, wala pa, which is mostly more on stairs. Okay? So, dito meron na tayong load dito. Dito sa side na to, meron na rin tayong load. Dito sa side na to, meron na rin tayong load. Ngayon, itong nasa taas natin, especially the girder along grid line D o grid line B. So, dalawa ang load na papasok dyan because you have the dead load due to this slab and you have another dead load due to this slab. So, meron naman siyang paganon. And then, eventually, i-add natin lahat yan to come up with the final SDL uniform load or member load. Okay, so sa stud, mas madali ito kasi ikakalculate niya yung member load. Dito, hindi. Medyo matagal. Nagmamanual kasi tayo. We need to determine member load in each member. Okay, so yung procedure na yan, gagawin nyo yan lahat doon sa plano ninyo. Intindihan nyo, class? So, pagka natapos nyo yan, madali na ang lahat. Yan lang ang pinakamatagal gawin. Kasi the rest, we need to calculate the seismic dead load, we need to calculate the column load, so madali na lahat. We can, if we want to design the girder of the column, mabilis na siya. Okay? So, ito lang yung medyo matagal ng konti. Okay. Next. Now, for this slab, since parehas naman ng dimensions nila, so pare-parehas lang yung 6 na yan. Again, this one is WS over 3. This one is what? Trapezoidal, that is W S multiplied by 3 minus M squared all over 6. Now, if we substitute, again, walang nagbago, 4.975. Ano ang nagbago? The dimension. The dimension of this slab is what? This one, 2.675. And then the other one is what? 2.85. This is 2.85. This is 2.675. So, if we substitute here, okay, and if we substitute WS over 3, again, 4.975, 2.675, yung S natin, over 3. So, we can calculate the value of our equivalent uniform dead load, 4.7 and 4.43. So, yung 4.7 tsaka 4.43, eto na yun. Dito meron kang 4.43, dito meron kang 4.7. So, 4.7, 4.7, 4.3, okay, so meron ka ng equivalent loads due to this slab. Yung slab na yan, yung load na yan, yan na rin load natin at the third floor, lahat-lahat. Bakit? Kasi pare-pares naman yung slab size natin. Magkakaroon lang tayo ng additional if there is an additional slab of different size. That is due to dead load. Next, that is due to live load. So, ganun pa rin dito, live load naman ang i-impose natin. Yan naman ang ilalagay natin. Again, we can calculate the following. So, 1.8 and 1.69. So, meron kang 1.69 dito, you have 1.8 here. Okay, class? Next. So, you have now one-way action. that is due to this slab. Okay? So, hahatiin mo lang sa gitna. Kasi maliit lang to, 0.45 lang to eh. This one, yung thickness na yan, yung clear span yan, that is only 0.45. Parang balcony lang yan o parang extension lang yan. So, kung 0.45, if you look, 0.45. Sorry class, mali to. No, that is not it's only 0. Dapat yan 0.225. Maliit lang yan. Mali yung ko 2.25 yung ginamit. Okay, dito 3.25 pa. Okay, this 3.25, this is for the stairs. This one is for the stairs. Okay? But this one is 0.225 lang yan. Not 0.45 because that is only 0.45. So that's 0.225, not 0.25. So this is now the load here. Okay? So weight is over 2. That's due to dead load. Okay, correct na lang natin yan. Now, consider the other one which is the live load. Okay? So yung live load natin dito both 1.9. Okay, 3.25. By 3.25, this clear. Okay, ito yung clear na yan, yung span na yan. Now inati natin siya sa gitna para pumunta rito. Inati natin sa gitna to be able to compute the equivalent uniform load. Yung ibang load pupunta ron. So again, that is 3.25. So okay, weight S. So this one is 3.25. Balik lang yung 3.25 yan. Yeah. 3.25. Ito nga pala. Saglit lang class ha. 3.5. Yeah. Ito yung hinati natin. Okay. Although this is now the short direction. Okay. This is now the long. Okay. But this one is, ito yung hinati natin. Okay, so this one is equal to 3.25. Since siya yung hahatiin natin, so therefore, that is 3.25 over 2. Convert from the rito. Okay, but this one, basically, this is mali. No? That should be 0.2. Iko-correct ko na lang, pati yung presentation na nandito, yung PowerPoint. So, ipapadala ko sa inyo. We corrected na. So, magkakasama na lahat, pati yung second two of them. Okay? So, you can calculate equivalent value. Okay? So, meron ka ng value dito. So, it should not be 1.6. Dapat yan lang. Dali. Check natin. 1.9 times 0.225. O, dapat 0.45 eh. Dapat yan, ang load mo rito, that is 0.4275. So, maiksi lang, maliit lang siya. Yun lang ang load niya. It should be equal to 0.45 over 2. So, mali yung natin, mali yung distances natin dito. Okay, sorry class. This one is 3.25. That is already okay. Okay, dapat ito 0.45. Okay, so this now is 3.08. So, tama yung load natin dito because that is the load of the stair. But this one is wrong. It should be 0.4275. That is due to live load. Okay? So, after which, we need to assume the self-weight of each member. Like for instance, we consider the following section. This is 150 by 300. This is 150 by 350. But the main girder, since that is approximately equal to 6 meters, so that is 250 by 500. Mahaba kasi yan, 250 by 500, 250 by 500. And then we calculate the equivalent weight, the self-weight. So that is B times H times 24 kilonewton per cubic meter. Like for instance, you have now 0.25 and 0.5, the section of the girder here. Okay, example times 24, that is 3 kilonewton per meter. That's why if you get the equivalent uniform load at the center, that is 3 kilonewton per meter. 3 kilonewton per meter. Okay, did you see that? That is 3 kilonewton per meter because they have the same section, 250 by 500. Okay, so again, the rest will be calculated based on their section. Like for instance, in this case, you have now 0.2 by 0.4 by 24. It is now the equivalent value. Okay, class? So again, that is the weight of the self-weight of the member. First, we need to assume the section of the member. And this could be used to calculate your self-weight. Okay? So malalagay mo na siya ngayon yung self-weight niya. Next, after which, we calculate since we are at the second floor, so ito yung floor-to-floor height niya, 3.5 meters. We subtract yung beam weight, yung beam height. Okay? Yung beam height. This is slab to slab. Okay? If we subtract the beam height, so therefore it becomes, I think, 2.1. Okay? So ang sabi natin, tingnan natin lahat kung nasan yung mga exterior wall natin. Along the exterior wall, we have this value. Okay, we assume the uniform load here to be equal to 2.6. Okay, for interior wall where there is an interior partition, we can utilize 2.1 kilopascal. Again, this 2.6 will be multiplied by the height, the equivalent height. But what is the equivalent height? That is simply equal to what? 3.5. Provided this 3.5 must be equal to what? Minus depth of the beam. Okay, but since we utilize that the thickness of the beam is 0.5, okay, which is 250. Okay, we assume that this one is simply equal to 0.5. Okay, so therefore that becomes 3. Okay, so therefore it should be multiplied by 3. Okay, so that is the 3 nga ba? 3 o ano ba ginamit natin? Okay, sorry class, no? Ang ginamit ko 2.5. So sa interior meron kang 2.10. Sa exterior meron kang 2.6. But we need to correct this 2.5. It should be 3.0. Okay? This one is I use 2.1. Ito dito yan. This one is interior. It should be 2.10 by 3. Okay? It should be 2.6 by 3. Not 2.5. Here I put 2.5. Okay? Kasi dito kasi ano ba tayo? 3.5 din ba? O 3? In-adjust ko. 3.5 pala. Kasi so gawin natin 3.5. So i-adjust na lang natin. It should be 2. Okay? So again, if you calculate the unit weight of this 2.10 is in terms of kilonewton per meter squared. Okay? Again, multiplied by meter. So it becomes kilonewton per meter. Okay? So we can convert that into a uniform load, which is this one. And yung nasa labas is 6.5 kilonewton per meter, but we need to correct that. It becomes what? 8. I think it should be 8.8. So 2.6 times 3. It will be equal to 2.6. 2.6 times 3 equals, it should be what? 7.8. This one, it should be 7.8. And then the other one is 2.1 times 3. It should be equal to, this one should be equal to, this interior should be equal to 6.3. Okay? So medyo kinorek natin ng konti. Okay? So therefore, the uniform load here is equivalent to 7.8. Nung nandito, 7.8 lahat yan, yung nasa exterior. Okay, dito 7.8 din. Okay, but for the interior, okay, our loads will be 6.3 tayo dito, 6.3, 6.3, 6.3, 6.3, 6.3. Intindihan nyo, class? Okay. So that is for the load. So, meron tayong tatlong klase ng load. The superimposed dead load. Okay? We have now the load, the SDL. After the SDL, meron kang member weight. Okay? Yung self weight. And then after that, we have now the wall weight. Okay? So pagsasama-samahin natin lahat yan.
I just hope Soyeon did
It's
all of it.
presented in the next slide. Okay? So sa next slide, magkakasama na sila. Meron kang load due to SDL, the superimposed dead load. And then you have now the load due to live load.
It would be so disappointing if Soyeon is not in all of it.
Member weight, yung nag-assume tayo ng dimensions of the beam, initial dimensions, and then the weight due to the wall. Okay? So, depende yan kung nasan yung load natin. Like, for instance, meron kang load dito, this one, plus the member weight, plus the weight of the wall. Since uniform siya, pare-parehas na meron dito, pare-parehas silang present. So, you have to consider this one. This load, pero magkaibang load natin dito on this grid, no? O on this area, tsaka dito sa area na to. So kasi pag pinag-add nyo sila, magsasama-sama yan. So this one plus this one plus this one. Okay? So iba ngayon yung magiging load, yung uniform load natin dito, ito total mo ngayon yan. Yan. Okay? Yan ang total dead load mo. Ito total mo rin yung nandito ngayon yan. So meron ka rin sariling dead load dyan. Okay? And then you have a separate item for your live load. So pwedeng ipapatong mo na rin yan. Let's say the red one will be the dead load, and then ipapatong mo ngayon yung live load mo. Ito ngayon yung live load mo. So ito rin ngayon yung live load mo. Nagtindihan nyo, class? So meron kong equivalent for the red one as your dead load, and then you have now a blue one as your live load. Okay? So ganun din dito sa kabila. You have now your equivalent load. Gaya dito, meron ka ring load dyan for the dead load. Meron ka ring load dito, mas mataas dito kasi meron ka pang stairs. And then after that, you have now the live load. Meron ka live load dito. Meron ka ring live load dito. Okay? So, ito total nyo na siya ngayon. Ngayon, ito, ang presentation nito is only for the second floor. So, gagawa kayo ng ganyan. Dapat you have to perceive the second floor, the third, the fourth, the fifth, the roof deck, and the roof level. Ganyan niya. Okay? So, for the meantime, yun muna yung kompletuhin ninyo. Okay? You can draw the loading diagram. You can draw the equivalent load. And then you can calculate the equivalent uniform load for each member. And then you can compute for the self weight of the member by simply first assuming the initial section. And then you can calculate for the loads due to wall. Okay? Kung marami pa kayong trabaho, okay lang. Question, class. Tanong. Tanong, class. May question ba kayo? So yan, gagawin ko ngayon. Itutuloy ko ngayon. Tapos i-upload ko. I-correct ko yung mga corrections na nakita natin. Okay? That is the summary for the second floor, third, fourth, fifth, sixth, roof deck, tsaka roof level. Any question, class? Ano? Mukhang wala na kayo. Nandiyan pa ba kayo? Ano daw isasubmit? Sabi ni Carrion. Hindi, isasubmit nyo sa huli na. Bigyan ko kayo ng yung plano ninyo, now showing all the calculations, ito kung paano ko ginawa, yan na mismo, ganyan. Yan ang gawin nyo sa plano ninyo. Susunod yan, di-discuss ko, sasama ko na sa presentation yung columns. Column loads, tapos earthquake, and then moment distribution. Okay. Maraming ano. Ito yung mga isasubmit natin. Thank you na pala. Okay. Yung mga isasubmit natin, one is yung ating architectural plan. Susunod, yung ating structural plan. Huwag mo na kang gumawa ng cover page, bibigyan ko kayo ng cover page, no? Yung simple lang. And then 3, sabihin ko yung design criteria. I-define yung design criteria kagaya kung paano ko siya present. Okay? And then next one is loading diagram. Next, load calculation. Okay? Yan muna. Hello, sir. Choose lang, ha? Hello. Hello, sir.
Oh, snap.
Don't let pimples distract you. Use Pond's Med Acne Solution. Stay clear in the zone.
Hold on. I thought Round Lee joined the yeah.
Eraser.
Eraser. Wow.
When I throw it back. Yeah.
Yeah, my ears, my phone ears. Uh, how far was me?
Oh, she did. She joined it. This one, see at the end of the song, play your song with the hashtag Sleep Continue. So like,
Friends.
she joined the hashtag. What is what is that? Oh, what? What? You read that? You got round two. Sponsored. Sponsored. Who spends an hour and 30 minutes talking about art? Very good. Oh, I remember.
Ano class, sorry nawala ako. Okay. Anyway, so ito muna yung gagawin ninyo. Okay? So, lahat yan, meron kang loading calculations. And then finally, kung meron kang loading calculations, dapat meron kang frame, meron kang frame, di ba meron kang framing system, framing plan. Yung sa framing plan, okay, basically dapat nakalagay dyan yung final loadings. Okay? So meron siyang conclusion, final loadings. Kasi pagka meron kang final loadings, madali na. Ang mangyayari, susunod noon, magpe-frame na tayo. Diba, meron kang framing, tapos meron kang final loadings. Halimbawa, second floor framing plan, you put all the loadings, yung total na. Dead load tsaka live load. Pero separated yung pagkakapresent ng dead load sa live load. Hindi siya dapat magkasama. Bakit hindi siya dapat magkasama? Kasi pagka nagkaroon tayo ng load combination, di ba? Pag nag-load combination lahat, tayo, let's say, 1.2 dead load, plus 1.6 live load. Tapos sometimes meron kang plus 1.0 earthquake. So, di ba? Kaya dapat magkahiwalay siya. So, susunod na gagawin natin yung ibang mga loads coming from the earthquake and the wind load para ma-push natin yung ating load combination. So, finally, pag nagawa natin yung load combinations, proceed na tayo sa design. Naintindihan nyo, class? Tinatanong niya kung type written. Hindi type written. Kahit hindi handwritten. Gawin nyo, i-CAD nyo para mas maganda. So, anything. Basta importante, magawa nyo itong mga items na to. Okay? Any question, class? So, magti-train. Alam ko, mga 3 o'clock lang yung ginawa ko. Any question? Any question? Tanong. Itong si Christian James. Baka mamaya may tanong. Itong si Miguel Escal. Carrion. Yan, may tinanong. Tinatanong niya, Sir, ano po ba sasubmit? Sir, handwritten or typewritten? So, mahirap pagka typewritten. O handwritten gusto nyo. So, anything. Okay? Mas maganda Excel nyo para mas mabilis kayo. Any question, class? Tanong? Question? Wala? Sige. O, kung wala kayong tanong, maraming salamat for listening. Okay? Dapat pala, nung pa natin ginawa yung ganito, no? Naintindihan nyo ba? Hindi. Assume natin, naintindihan nyo. Sulat mo na nga lang. Wala, nahihiyang magsalita yung mga yan, kaya wala silang mic. Okay class, kung meron kayong any questions, any inquiry, okay, pwede kayo doon sa chat group natin, ha? Di ba hindi ko kayo nasasagot doon, no class, no? Kasi minsan hindi ako nag-open eh. But anyway, ilagay nyo lang doon, tapos sasagutin ko na lang kayo in class sa course message. Okay? Any question? So, gagawin ko ngayon gagawin ko yung ibang framing system, yung ibang framing plan, para pag in-upload natin, corrected na, and then kompleto na siya. Kasi pagka nagawa natin yung lahat ng frames natin with final loading, then magpuproceed tayo sa column load, seismic load calculations, And then after that, frame analysis na, after frame analysis, so mabilis na lang siya na. Okay? Question? Okay, class. So that's all for today. Maraming salamat sa inyong pakikinig. Thank you very much. Salamat. Oh, sige. Okay. Pero sigurado kayo, naintindihan nyo? Sige, okay na nga. Thank you. Okay, you can leave and you can perform your activity. Okay? And you can do your workout. Okay? You can proceed with your workout. Sige. Ililib ko na to. Maraming salamat. Okay, you can leave. Okay. Dali. May set ba? Okay. Sagutin ko lang si